So when we talk about small prisms, what we are talking about is the angle of the prism has to be less than 10 degrees. Okay, that's what we consider it to be a small prism, like what you guys are seeing in the figure. Okay, now you have ABC. Now AB is the face where the light ray is incidenting, and AC is the face where the light is emerging, right? Okay, see, now what we are looking at is deviation through a small prism. Okay, when we talk about small prism, remember the angles will be very, very small. Okay, fine. Now at the surface AB, what we have is mu is equal to sin I by sin R1, right? Since the I and R1 are very small angles, sin I and sin R1 can almost be equal to I and R1. So what we get is mu is equal to I divided by R1, right? In other words, I is equal to mu into R1. Okay. Next is same. See, for the emergent surface, that is AC. For this, we have mu is equal to sin E by sin R2. Here also small angles. So we get mu is equal to E divided by R2, or E is equal to mu R2. Okay. Next, for minimum deviation, what we know is A plus delta is equal to I plus E, right? So we have delta is equal to I plus E minus A. Now I and E, we already know the formula, that's what we derived. So what we have is mu R1 plus mu R2 minus A. So if you take mu common, mu into R1 plus R2 minus A, correct? Now what was R1 plus R2? That's nothing but the value of A, the angle of the prism. So if you substitute, we have delta is equal to mu A minus A. So if you take A common, we get delta is equal to A into mu minus 1. So this particular formula gives us the deviation caused by a very small prism of angle A. Okay, again I am repeating, whenever we talk about a small prism, what we are talking about is the angle of the prism being less than 10 degrees. Okay, so this is the formula, delta is equal to A into mu minus 1.